Welcome to this presentation on Master Functions and Object-Oriented Programming Concepts in C++. My name is Joseph Toby and I am excited to guide you through the key aspects of these essential programming concepts. By the end of this presentation, it will have an explanation of functions and object-oriented programming principles like abstraction and encapsulation, and make code more efficient, secure, and easy to maintain. First of the main purpose of this presentation is it's a jump into a model of programming functions and deep dive into the powerful world of object-oriented programming, or OOP. We will cover the key principles of functions and object-oriented programming, and some examples, explore how these concepts are used in real-world applications. And so let's get started. From the first slide, functions in C++. What are functions? In C++, a function is a block of code designed to perform a specific task. It allows us to organize code into smaller, reusable pieces, which can be called whenever we need it. Instead of writing the same block of code multiple times, we write it in once in a function and call it whenever necessary. And how do functions help in programming? Functions provide several key benefits. Modularity. Functions help break down large, complex programs into smaller, more manageable parts. And reusability. Once a function is written, it can be used multiple times in different parts of the program and or even in the other programs. Ease of debugging. With functions, it is easier to isolate problems and test individual parts of the program. An example of a simple function is provided below. Here the function calculate area accepts two parameters, the length and the width, and returns the calculated area. Functions help organize code and make it easier to maintain and debug. Benefits of function. Thinking of functions like recipes. If you want to bake a cake, you follow a set of repeatable steps. Similarly, functions provide repeatable steps to achieve consistent result. Example use a case. For instance, if you are building a financial calculator, you might write a function to calculate task, interest, or loan repayments. These functions can be reused throughout your program. And next is an overview of object-oriented programming. What is object-oriented programming? Object-oriented programming is a programming paradigm that uses objects to combine both data and functions. Instead of thinking about individual functions or variables, we focus on creating objects that represent real-world entities. The key features of object-oriented programming. In object-oriented programming, we have two primary components, classes and object. In a class, a blueprint for creating objects. A class is a blueprint for creating objects. It defines what data and functions an object will have. Because an object is an instance of a class, representing a real-world entity. And here are some advantages of object-oriented programming. Object-oriented programming makes code more modular, allowing you to break down the program into smaller self-contained parts. It models real-world systems more effectively, making it easier to simulate objects like a bank account or a customer. Object-oriented programs promotes code reuse through inheritance. It means that the new class can inherit features from existing ones. Example of class and objects are provided. Here in the example, the class has a model and a start function. An object of the class like my car and can be created and used to represent a specific card in the program. And then for the next slide, OOPS concept in abstraction and encapsulation. From the very first we start from abstraction. Definition of abstraction, like abstraction simplifies the complex systems by exposing only essential features and hiding the unnecessary details. It's like driving a car. You don't need to know how the engine works. You just need to know how it operates. Why abstraction matters? Abstraction helps reduce complexity for users, allowing them to interact with systems at a high level without being overwhelmed by all the intricate details underneath. Technical example. Considering a calculator class that has an add function. Use class calculator in public int add, int x, int y, return x plus y, integer subtract, int x, int y, and return x minus y. The user does not need to know how the add method is implemented internally. You just call the function and get the result. And real world example of it is thinking of like we are considering a ATM machine. We don't need to know how the ATM communicates with the bank backends or how it counts money. You just need to press a button to withdraw cash. This is abstraction in action. Benefits of abstraction. Abstraction reduces complexity, improves usability, and enhances security by hiding implementation details. The user interacts with a simplified interface, making the system easier to use and less prone to errors. And the next topic is encapsulation. And the definition of encapsulation is a practice of bundling data and the method that manipulate the data within a single unit or class. It also restricts access to some of the object's components, ensuring that the object internal state is protected and only accessible in safe ways. Why encapsulation matters? Encapsulation helps to safeguard the integrity of data by restricting direct access to it. This ensures that the data cannot be altered in unintended ways. Examples of encapsulation is provided, like bank accounts. Here, the balance is private, which means it cannot be accessed directly from outside the class. The only way to interact with it is through the deposit and get balance method. And some real world energy examples. Imagine a bank vault, and you as a customer and cannot directly access the vault, but you can interact with the teller to deposit or money withdraw. This is how encapsulation works. Users interact with controlled methods rather than direct access to the internal data. Benefits of encapsulation. Encapsulation helps in protecting data from unauthorized access. It also simplifies code maintenance because you can sync the internal working of a class without affecting other parts of the program. Real world application. Functions are widely used in various applications such as financial software, data analysis tools. In financial software, for tasks like tax calculation, interest computation, and laundry payments, and data analysis tool, where function break down complex process into smaller reusable steps. Next is all about object-oriented programming in action. And object-oriented programming principles like abstraction and encapsulation play a huge role in design of large-scale system, including online banking system, simulation tools, etc. In online banking system, encapsulation protects sensitive data while abstract simplify users and interactions. In simultaneous tools, abstraction helps manage complex models while encapsulation ensures data integrity. And I'm concluding uh, by recapping some key points. To summarize, the function allows us to organize code into modular, reusable pieces, making programming more efficient. OOPS principles like abstraction and encapsulation provide powerful tools for modeling real-world systems and ensuring the security and integrity of the data. And some of my final thoughts. Combining the power of functions with the principles of object-oriented programming makes your code not only scalable and maintainable, but also more secure and easier to manage. I'm concluding. Thank you.